thank you very much for coming. I know some of you have travelled some considerable distance to be with me here tonight, and I say thank you for that immediately. A rather long title, and for a inaugural lecture. Inaugural lectures have a long history in this university, and this gentleman, Sir Charles Bell, gave the first in 1828. I decided not to replicate the hairdo or the wing collar, but we did decide to use formal attire because we think it is an important sense of occasion, not only for me, but I hope for the centre that we're founding here. So the outline of what I want to talk about today is, first of all, to give you a little bit of background about me. Why did I get interested in infrastructure? As I've got interested in infrastructure over the last 4 or 5 years, I've started to realise it came from way back in my childhood. Then I'll talk a bit about what some of the current issues are, what's happening, and then finally I'll talk about what we're planning to do at UCL in the Centre for Engineering Policy. So where did it start for me? Well, it started because I grew up just after the end of the Second World War. And although I didn't see a map like this of bomb damage, V1 and V2 damage to London until much, much later, I grew up in streets which had been affected by bombing because I grew up in southeast London. And although this isn't southeast London, it represents a good example of a map showing where damage had occurred. And wherever it's coloured, there was damage. Doesn't matter what the colour is for the moment, you can see the colour coding, and you can see one big circle, which was a flying bomb, and you can see just a little bit of another one off to the right-hand side. I grew up knowing that this sort of thing had happened and that the world around me in suburban London had been severely affected, and at the age of 5 I really didn't understand what, because everyone talked about the war and seemed very happy, because actually they were happy because it had finished. What I then realised was certain parts of London were more like this, and this is what happens if a V2 lands close to a set of houses. Well, you can see where most of it landed, and you can see that a significant fraction of the houses don't have roofs. The penultimate V2 landed at the bottom of the road in which I lived, and had it not hit the top of a 40-foot elm tree, I wouldn't be here talking to you, because my mother was carrying me at the time. It did take the roof off all the houses in our road. We had the only functional toilet, I was told, which you can imagine caused huge logistic problems. But that's the sort of damage that was present in quite a large fraction of southern London, because as some of you will know if you've read your history, we actually managed to tell the Germans that they were landing in the north of London, so they withdrew the range and pulled them back into the south of London, which was great for anyone in the north or middle of London, not so great for anyone in the southern end of London. So that's the sort of carnage that was present. What I then realised much later on, that what my father did, he was quantity surveyor for Middlesex County Council. Some of you will remember there was a thing called Middlesex County Council, or it disappeared in the 60s. And his job during the war, he had a reserved occupation, was to go round every morning after the bombing and make that decision. Now that was and that's not my father, my son. So you're confronted with people in the streets, bodies buried in rubble, and your decision is, do you keep the building, pull it down because it's unsafe, and then what advice do you give with regard to rebuilding it? And he did that day after day, day after day. And then another map on the right-hand side showing again the example of the level of damage to the infrastructure of the country, because it isn't just the buildings, it's all the roads, it's all the underwater plumbing, it's the electricity, all the things we take for granted. And I guess I grew up knowing that this was the sort of thing that had happened and that infrastructure had been badly damaged. I also knew what Rosebay Willow Herb was before almost anybody else around me, because I got interested in wildflowers, because Rosebay Willow Herb populated most of the bomb sites. It's one of the most durable weeds or wildflowers growing in the wrong place, depending upon how you look at it, that populated the whole of London and is in fact the county flower of London as a result, because most of London went purple as a result of Rosebay Willow Herb growing all over it. So enough of the doom and gloom. I grew up in the era, therefore, of where all of that was being rebuilt. And for the next 15 years, from 1945 to 1960, most of southern Britain was being rebuilt and its infrastructure replaced. My father by then had got an easier job in the sense he was still quantity surveyor, in fact chief quantity surveyor for Middlesex County Council, but instead of looking after the rebuilding of bombed buildings, he started looking after other houses which were much more interested. So these are the houses that my dad looked after. Most of them are either hotels or luxury apartments now, but at that time they were residential homes for children who didn't have homes of their own. And so I went with him on school holidays because his job was to maintain the infrastructure of these houses. And that's the heating, the lighting, all the services that went into them. Not national infrastructure, but substantially large buildings, stately homes as they were before the war, which I then got a feel for what it took to make a very large house work. Gillian sitting up there say, I must have forgotten it because we don't seem to do that at home at the moment. But so I learned at quite a young age things about plumbing and about electricity and about roofs and joists and all sorts of stuff that most people of my age, 7, 8, 9, wouldn't have known about. But they were fun days out because some of these are way out in the country in some very spectacular places. So that's what happened, and then I went to university and did a degree and stuff like that. And then I got my own office, and this was the view from the first office I ever had. Because by then I was doing astrophysics, and the dome on the right-hand side was mine, and the French looked after the one on the left, and we both had a spectacular view of the Matterhorn, and we both commuted on the Gornergrat mountain railway up and down to Zermatt for a year. But as you can see from the left-hand side, nothing changes about academic finance. And in 1973, the money ran out, and I had to go and get a real job and leave Oxford. So very quickly, however, one thing to say, of course, I then learned about the infrastructure of mountain railways in the snow and how to make sure they functioned properly. And of course, the Swiss, being the Swiss, made sure they did function properly. There was only one day when I was there that train did not run. We had 9 meters of snow. Sorry, 9 feet, 3 meters of snow in 24 hours. That stopped it for a day. So then I went on and got other office views, and the office views I had varied. On the left, I spent 17 years at RSRE, that's the view of the Malvern Hills, and then went and got a job in and around the city on one of those jobs overlooking St Paul's, which was fabulous. Then went back into academia, and that's the Library of Shrivenham on the bottom left-hand side. And then in Biz, I had the privilege of working in a building that overlooked Westminster Abbey, and rather than show you a picture of Westminster Abbey as it is now, that's a painting by Canaletto in 1749, and you'd be pushed to find the difference. So it just shows that some parts of our infrastructure can be around for quite some time, and we walk around London as Londoners and perhaps don't even notice the fact that some of these buildings have been there for a long time, and we need to look after them more carefully. So those are the sorts of pieces of infrastructure that I've had engagement with, rural and city and heritage. So the toys that I looked after, and Anthony very kindly did mention GCHQ, you would expect GCHQ to have something like that, and that's the satellite view of the same facility. So I had the responsibility for one of those. And I learned what high winds do to satellite dishes if you can't stow them quickly enough. They turn into sails and they get picked up and blown away, which is what happened to a 30-ton satellite dish, £2.5 million worth. It took about 10 seconds, which was seriously embarrassing till we realized actually the meteorological conditions were extremely unusual. So that was one of my toys, which we then had to replace. Not really a toy, I must admit. This is another toy that I had on top of a mountain in Cyprus, which was of great strategic significance and still is. So that was another element of my activity. The one that I enjoyed most was this one, which we'll get in the right place in a moment. That one is a similar facility, but it happens to be in the wine growing area of the northern part of South Island in New Zealand. And I had the privilege of opening it. Anyone remember this was 1990? In 1990, anyone who knew anything about New Zealand wine was probably a Kiwi. I discovered Marlborough wine by going there in 1990 and discovered this nectar that we now all drink, at least I think it's nectar. And I had the privilege of opening that facility when I was there. It's buried in the mountains, but also very close to the vineyards. And then hardly one of my toys, but one of the areas that I also look back on with some pride is this is an aerial photograph of Hingston Hall, which is where the Human Genome Mapping Project was run from by the Wellcome Trust, where I also worked briefly in the mid-90s. And I program managed the IT infrastructure for that facility, which of course by the end of that decade had mapped the human genome, one of the most significant breakthroughs in science. So although that was a very small piece of the whole activity, I did have some involvement in that. I thought I'd also mention another example of a piece of infrastructure which I've been party to the development of, which is this crew. This crew is the club of chief scientific advisors, which 10 years ago didn't exist and now extends across all government departments. Partly started by Sir David King on the left, who was obviously trying to weigh the size of the planet, and on the right by Sir John Beddington, who looks worried. In my time working with him, he had quite a lot on occasions to be worried about. And I'm not sure where the picture in the middle came from, but Jeremy, sitting here as a current CSA, will probably want it from me in order to tease Sir John with. And then this crew underneath, one of whom Jeremy is sitting here in the middle, and me sort of gesticulating as I quite often do, and David Mackay doing difficult sums, which is what David tends to do best. But in the middle, someone who isn't a chief scientific advisor, it's Sir Adrian Smith, who's the Director General for Knowledge and Innovation in BIS, who basically looks after all the Research Council budget, having a gentle conversation by the look of it with our provost. And they both have wine glasses, which also indicates the level of conversation, I think. So that club of CSAs is a social network, a piece of social infrastructure, which is transcending government departments and causing them to think in a collaborative way about science and engineering in a way that they hadn't been able to do before that network was created. And I felt that was a really significant achievement during the last 5 to 6 years of the last decade, that we managed to put that in place. And quite importantly, Anne Glover there, who was the chief scientist for Scotland, is now the chief scientist for Europe in the European Commission. And she clearly has got a huge job on her lap to deal with not only the Eurozone issue, but the Euro currency issue, but also how to get science across Europe into a better shape. So some of the lessons I learned, firstly, is that we have an expectation that government's joined up, but it isn't. And any policies that come into effect after the next election aren't relevant. This is not news to probably many of you. That thinking about things in a sustainable way, remember the first word of the title of this lecture is sustainability. It's not on the agenda because it doesn't last long enough. And this, I think, is probably most important. So basically, every time we get an election, we've got to do new things, almost by default. And because we change parties, if we don't change parties, it's easier. But if we do, then things have to change. There are exceptions. Crossrail is an exception. There are one or two others. But generally speaking, we find policy instruments move around. The market looks after most of the infrastructure, and I'll show you some numerical data later on that indicates just how that works. Each one is regulated individually and tends to be operated at a local level. There are some exceptions to that, but most of them are operated at a very local level. And yet our experience of infrastructure is not like that at all. So there's a mismatch between our understanding of infrastructure, the sorts of services that we expect to use all the time, and how they're actually regulated and operated. And what politicians think they have now discovered is how to have devolved responsibility and authority without understanding that they haven't devolved accountability. So when things go wrong, and I witnessed snow, ash, strikes and floods during my tenure as chief scientific advisor, they had no tools left to do anything about the consequences, even though the public and the media held them very much accountable. So those were the sort of critical lessons that I learned. However, there were some huge positives, and that was that it was a great privilege to be where I was, influencing public policy and hopefully improving things just a bit in the areas that I influenced. So what is good infrastructure? Good infrastructure are those things, energy, transport, water, waste, information, that we take for granted are going to be supplied at a national and a regional scale. They're going to be of sufficient quality to support us as a developed society. We think we live in a developed society. I found very few definitions of what a developed society actually is, but we all seem to know we live in one. We know what a developing society is, but we don't know what a developed society has to have as its properties to maintain that. Increasingly, we're undergoing shock, so we have to be resilient to that, and we also have to have that infrastructure well managed, and it has to attract continuous investment, because otherwise it just decays. So we have to keep pumping money into it. And what we've observed is, at least over the last 20 to 30 years, we haven't been pumping anything like enough money into our infrastructure. Now, that is a statement I could make about most countries on the planet, let alone us. So actually most developed societies have made the mistake of not attracting continuous investment. However, if you do it properly, and this is the King's Cross development, just to the north of King's Cross, this is an example of where all of those things were thought about at the design phase and has been used as an example by the Treasury just recently to show how well things can be done in a joined up way, and how much money can be saved and how much more benefit can be accrued by looking at in this case, a geographically co-located entity that contains a lot of different infrastructural components in a holistic and systematic way. So that's the nature of it, but our history is that actually we built most of it in the 19th century. And at that time we were a world leader in water, waste, long distance road and rail. And we still got a lot of it. We expanded national infrastructure after the replacement at the end of the Second World War, motorways, nuclear power, North Sea oil and gas. Then we privatised a lot of it and pushed it out into the market in various different ways with different regulatory structures in order to get a market-driven efficiency into infrastructure service provision. And then we looked at other ways of looking for private sector engagement, and indeed are starting to do that again. But the problem we've got is the engineering of it is ageing. We have over 40,000 bridges we don't know the state of, and we've set ourselves some really challenging targets, particularly in relation to energy generation and decarbonising most of our infrastructure. So, to summarise, we started it 150 years ago. We more or less completed most of it 60 years ago. We haven't done much since. Our population has grown and we work and live differently from how we did when we built a lot of this stuff. We've privatised it and we don't have any central governance of any aspect of this as a system. The Council for Science and Technology, which is the Prime Minister's advisory body, chaired by the Government Chief Scientific Advisor, currently Sir John Beddington, produced a study in 2009 which demonstrated all of these arguments. And I was present in number 10 briefing Lord Mandelson because the Prime Minister, Gordon Brown, wasn't available. And Lord Mandelson asked the question of us, who's responsible for infrastructure? He didn't actually know there wasn't anybody, which was embarrassing when we told him. It was even more embarrassing because his response was that, well, his grandfather had nationalised it all, so what had happened since then? And his grandfather, Lord Morrison, had nationalised it all, but in 1948. And really, they hadn't taken a huge amount of notice of it since then. This is the sort of physical object I'm talking about: coal-fired power station, nuclear power station, close to the sea, as they have to be in order for the cooling, wind farms, which most of you will have seen at some part of the world, and an aerial shot of something which I travel by most days. It's the combined heat and power plant in southeast London. One of those areas where you would have thought, actually, that's quite a clever idea, because cities produce lots of municipal waste. Why don't we turn it into local heat and power close by? There aren't many of those yet, because the local communities don't seem to think that's what they want on their doorstep. They just want their waste to disappear, please. Well, that is actually a good example of where we've done that properly. This is the sort of infrastructure at national scale. This is the national grid. These are pylons marching across the landscape and substations which convert it down to lower voltage for local usage. A little bit about transport. The history of our transport is that every mode of transport, from turnpikes through canals, through railways, through trunk roads, through motorways, plateau before they get taken over by the next version of infrastructure. When broadband's finished, I want to plot that on this curve and show what that looks like, because, as it were, that's moving bits around and moving us around virtually rather than really. But as you can see, the appetite for continued investment tails off as a certain capacity is reached and this is over 200 years. This is a railway map on the top left in the just before the First World War, 1905, of the map of central London. This one's 2005. If you look at those maps in detail, you can find very little has changed. The railways that were laid down at that time, 100 years ago, really haven't moved very much. And it's not surprising because they're in urban areas, they're in suburban areas, and it's very difficult then to move them once you've built everything around them, which of course when they were first built wasn't the case. So urban railways tend to dictate an awful lot of how cities then behave. And if cities then want to behave differently, the transport system either has to be ripped up and done again in some different way, or it has to be tunnelled underneath, which of course is exactly what we're doing. We did do with the Tube and we're doing with Crossrail Thameslink as a modernisation programme in London. Now, most of you who live in and around London will recognise this. This is the map of where the roads are, right? Unfortunately, it's the map of where the Roman roads are. And they haven't moved very much. So never mind 100 years, we're talking 2,000 years. I mean, I'm being glib in saying this, some of them of course have moved, but most of the big arterial roads, the original A roads, are pretty well co-located to where the Romans first built them. So again, we're stuck with our heritage of where we did the civil engineering, where we did it, the Romans did it. This is the London Underground system in italics, because London Underground is not run as a system, it's run as a set of individual railway lines, underground lines, which don't necessarily talk to each other very richly. They're beginning to talk to each other more richly than they used to, but it is still a long way to go, let alone talk to surface and other modes of transport. So although you might look at that and think, as a visitor to London, I could use this as a system, you can't. And one of the things that's then happened, of course, is away from London in particular, away from cities, there's been a huge growth over the last 50 or 60 years in the use of cars. You can very easily see the decline in bus, coach, rail travel, which of course is now beginning to pick up again, and other forms of travelling, cycling included, which of course is now beginning to pick up. But it's a very minor dent in what is happening across the whole country. Again, a lot of the media tend to talk about what is happening because as if these revolutions are happening because they're happening in London. If you live outside London, the car is absolutely vital to your survival. You cannot live without one because all the other modes of transport, generally speaking, are just not available to you. However, the most rapidly growing vehicle type on our roads isn't the private car. It's light vans, which maybe won't surprise you too much because it's the growth of the small business being mobile to move their business to wherever they want it to be. So you can see that the growth in all the other vehicles is relatively slow compared with the rapid growth in light vans. And that means in our context, we have to deal with, in planning context, in transport, very heavily congested motorways carrying a lot of freight or carrying lots of cars, ports that are taking most of our heavy freight in and out of the country, most of our food and heavy materials. We have an airspace that is incredibly congested over the southeast of England, less so elsewhere. And we have railway systems, Clapham Junction, as this example shows, which has been pretty well the same for an awful long time, and that's one of the busiest intersections. And just so that you know that I'm not only thinking about this in a London context, this is Cardiff, and the Bay development in Cardiff has transformed some of the aspects of living in Cardiff by changing people's attitudes to the use of the harbour, but with a fair amount of reconstruction, as you can see. And where it's more difficult, Liverpool, which is still one of our major freight ports, it is more difficult to think about changing too many things too quickly, but that is happening. So a lot of the discourse that comes from the media is London-centric, but a lot of what's actually happening is outside London and is vital to our economy. That's the infrastructure. What we then drive on it are high-speed trains. We drive low-carbon buses. We're increasingly using coastal shipping in a way that we used to until the Second World War, but we're beginning to put it back because we're beginning to see the merit of taking medium-sized freight cargoes off the roads and off the rail. But we need ports development. Certain parts of our coastline are very heavily congested by luxury leisure boating. And our airports, particularly in the southeast, are very heavily congested. And occasionally, things go drastically wrong. This one was full of BMW parts, and keeping the scavengers off it for 18 months while it was salvaged was a major problem for the Maritime and Coast Guard Agency. So the platforms matter as well, because that's where a lot of evolution and innovation is happening in order to deliver our low carbon environment, but on the back of a fairly difficult infrastructure to transform. You would have expected that most of the traffic is either around cities or on motorways. 30% of the traffic in this country travels on motorways. It's only 1.5% of the mileage of the roads. Because, well, it looks as if that's the quickest way to go from A to B. Maybe the shortest, but it probably isn't the quickest. And these sorts of maps show that most of the roads of this country are empty most of the time, which is daft. We really should be making much more intelligent use of our infrastructure, and that is one of the areas, of course, of innovation that we can see coming in modernising our infrastructure through the combination of good civil engineering and good information and communications technologies integrated together in terms of policy. It's almost the first time I've said policy, but it's one of those areas which is beginning to bite in a community called the Automotive Council, which is co-chaired by the Secretary of State for Business Innovation Skills and a leader from the automotive industry. And they published a very useful report called Intelligent Mobility last week, which will play to a lot of activity that certainly I've been involved with, certainly one other person in the audience has been heavily involved in during the last 3 or 4 years in developing our leadership position in that area in the UK. Now, aviation is one of those areas which, of course, is pretty topical right now. The concept of having another runway in the southeast of England, Heathrow or somewhere else, is as a response to this sort of curve, which, as you can see, has been going up and up and up. The odd blip due to oil price shocks, other perturbations like 9/11, but generally speaking, more and more people want to fly, and it looks as if that isn't going to stop. And to give you a feel for what that looks like, and so you don't have to listen to me for a minute and a half, this is a day in the life of global aviation. Each dot is an aircraft. And you can see the sun, you can see the dark just moving off this side right now. So you can see Europe light up in just a minute as dawn arrives. And you can see America sort of go to sleep. And then Europe lights up. Asia, of course, is pretty busy. And then all of a sudden, dusk arrives, nightfall arrives on the right-hand side, and Asia starts going to sleep. And then dawn arrives in the United States, eastern seaboard lights up, Midwest lights up, California lights up. Asia by now has gone to sleep, Europe's very busy. And that gives you a feel for what's going on in aviation around the planet on any given typical day. And you can see where aviation has to go in order to deliver what we take for granted as our right to fly anywhere on the planet pretty well at will. And you know, the number of movements, of course, is absolutely colossal. Would you like to see it again? So there are one or two things which I found very interesting for personal reasons. There's this, pointing at the wrong thing. There's a little dot down there. Gillian will know what I'm talking about. That's the flight from Sydney to Johannesburg. Divert? Forget it. Nowhere to divert to. 13 hours? 13 hours. That's a bit scary. And there's some up over the north, which you'll see later on when it's dark, that you can see going right up over the northern end of Siberia. Again, pretty hairy if you thought, well, what happens if anything goes wrong? And this is on YouTube, by the way. You can download it and play with it and look at it. But I think it's fascinating to look at just where the density of traffic is, what it does in terms of time of day, and so on. In fact, there are quite a few animations like this now showing various aspects of aviation on various specific days. There's a really good one which shows on 9/11, for all the wrong reasons, of course, how aircraft over the United States stopped flying, and you can see the decay of that in about an hour and a half. So, day in the life of aviation, and that means we have to worry about our role in the projection of that capability across the whole of the planet. Water, a very topical subject as well. This is what we use water for. So what are we doing in order to reduce the amount of water we use? Hosepipe ban. That's the outdoor bit, right? So that's going to make a big dent, isn't it? Actually, the bit we need to address is not how often we flush our toilets, but how much water we use, commensurate with public health, which of course has to be paramount, and whether or not we spend as much time in the shower and as much water using in our washing machines. It's the big sectors that are going to make the big difference, and those aspects seem to me to be neglected in policy making, because this sort of number is interacted with the impact on what people perceive the government imposing on them if they impose limitations in other areas. So outdoor use is not seen to be particularly invasive, and it seems to be quite sensible, but in actual engineering terms of how much water, it doesn't make a big difference. And where it would make a big difference, of course, it impacts the politics head on. Water, of course, is also something we try to move around, and this is a map of, from some time ago now, of some of the planning that was going on to move water around the country, and those plans are now beginning to come to greater fruition. But unfortunately, nature moves water around all too often without us wanting it to. This is a map you can take off the Environment Agency, which shows the flooding in the Thames estuary under worst-case conditions of failure of the Thames barrage. We're okay here, just about, but as you can see, a significant fraction of London goes under. Not a pleasant sight. And of course, it does happen for real. This is a real satellite photo of the flooding on July 2007. I wasn't very far away from this in July 2007. And you can see where the blue is, and that is a significant amount of flooding on the 7 floodplains, which of course has caused a huge amount of inquiry, a lot of studies now, a lot of flood management programs coming out of DEFRA as a result of the PIT review, which was the review that was carried out as a result of this incident. So that's the physical infrastructure. We also now have a virtual infrastructure. If you remember, I talked about information. This is the 3G mobile coverage. It's changing all the time, so this is a snapshot from a wee while ago, so it's getting better all the time. And this is broadband, where of course it's much denser, and so what the colour coding is do you have choices? And where it's red, you only have one choice, which of course is the argument about BT offering up other access points to other providers. And again, this is a snapshot from some time ago, so it's getting better. So we have really good broadband coverage. Actually, we have better broadband coverage than a lot of the media would have you believe. And 3G, and about to become 4G, of course, is growing very fast. Now, what that physically looks like is racks and racks of kit like this, which are sat in data centers and switching centers all over the country, consuming electricity. And the consumption of electricity to run this stuff is quite a significant load on our electricity. It's about as much as, in terms of carbon footprint from our electricity mix, as aviation is. People don't know that. The media won't tell you that aviation is no more a culprit for carbon production through its use of electricity, through its use of fossil fuels, than IT is in the use of electricity that is derived from burning fossil fuels in power stations and producing electricity. So the IT industry also has a job to do to reduce its carbon footprint, because we are getting more and more reliant on very large data farms and switching centres to run our ICT infrastructure. And all the bit we see is those things. We don't think of what's actually going on in terms of the infrastructure behind it. Not only in this country, but if we want our mobile phone to work anywhere in the world, all the other countries have got to do it as well, otherwise it won't work. So the whole infrastructure piece is pretty important to the delivery of information to our handsets to do what we want to do and make our decisions to use intelligent transport, to use intelligent metering in our houses, and so on. And energy use per capita, although it's plateaued, actually we've got to reduce this. We've got to reduce it by 80%. It's got to go down very fast, and all the indicators on energy consumption are going in the wrong direction. Now, this is 2010 numbers. Certainly in the last year, it looks as if it might have got better, but that's because people have less money, not necessarily because they have any perception they want to use less energy. So energy efficiency and energy economy are still really difficult areas in terms of engineering policy and social policy and political policy mixed together. So the Prime Minister 2 weeks ago today made a speech about infrastructure. It was the second time David Cameron has made a speech about infrastructure, and I don't think any Prime Minister had made a significant speech about infrastructure before. So this is good news. And here's some extracts. You can read the full speech. It's on the Number 10 website, reference below. And this reinforces what some of us have been saying to government for the last 3 years. So you think, great, they've heard it. And then you get this paragraph, which, you know, it gets power to our lights, water to our taps, and so on. And we have created a national infrastructure plan, which I've helped create. And that's the objective. However, there's one word in this lot which made my blood boil when I read it, and it's that word. The one thing it is not is magic. It is good engineering. And I think that's been the delusion, that's been the issue that politicians haven't faced up to for quite a long time. They expect to be able to shut their eyes, wave a wand, and the infrastructure gets better. Someone else does it. And actually you need policies that make those things happen through investment, through good design and good engineering and good operation. And that's the bit that we've been missing. So we're going in the right direction. We have a national infrastructure plan. This is a global infrastructure ranking from the World Economic Forum, one of a number of rankings, none of which I believe totally, but it's better than some. And it shows where infrastructure is good, and we're in a good place, but not heading in the right direction. And there are other countries which are getting better and others which are getting worse. But as you can see, most of the world actually doesn't have infrastructure anything like as good as we have. So, another objective of having a good understanding of how to deliver good engineering policy is export. Because most of the rest of the world needs what we have. Except that we don't understand at the moment how to develop policies for doing it for ourselves, but if we did, then we could start helping other countries to deliver much more effectively their own infrastructure to make their own livelihoods better. So apart from the commercial reasons for doing that, there are clearly very substantive ethical reasons for doing that. And this sort of map shows you where you might attempt to start that process, and indeed, that is happening. So the outline of the National Infrastructure Plan, it's a 128-page document, so I'm not going to dwell on it for too long. You can read it if you suffer from insomnia. Is first of all, where are we? It's nice to know where you are before you start moving in any given direction. And this is the Treasury's evaluation of the performance of infrastructure and its evolution of cost, which of course the Treasury is particularly worried about, since 2005. Now I think this is pretty optimistic. I don't think we're anything like as good as that, but that's what the Treasury seem to think is the case. Partly to sell the argument, I think, to ministers. However, on the right-hand side, I think we get a slightly bigger taste of realism, which is, as it were, the asset state, how well we're using it, and what the service quality is that we can derive from it. Again, I think there are too many up arrows. There's not enough horizontal arrows. But I wouldn't disagree with some of the down arrows, and that is causing investment plans and thinking in Treasury with regard to what to do next. I said I would say something about where the money came from. On average, 60% of the money is private money, and about 15% is public money, and the rest is a mixture. But that's the average across the top of those bars on the right-hand side. When you come down and look at each sector, every sector is different, radically different. So the average is probably meaningless. And as a result, when you start talking about building infrastructure which contains all the components, which most large infrastructural developments will have, then you end up with a mixture of financial models, which is a real nightmare, because all of them come from different sources in different mixes. Intellectual capital, by the way, is the research base. It's the knowledge base that is funded largely by public money, but not entirely. And again, I'm not sure I believe that number, because actually it's quite difficult to get hold of what private sector investment is in this space. So actually, it is true that most of it on average is funded by the private sector, but it's more complicated than that. And more private finance is going to be needed if we're going to spend the best part of 100 billion over the next 10 years modernising, which is the number the Treasury believe is the right number. So we need new investors, new business models for sources of revenue, more local optimisation, but in the context of a big plan, and we need some guarantees to get over the short-term politicisation. Again, a map that shows where some of the projects are being done. I'm not going to dwell on the detail, because I'm sure you can't read it, but it shows how well regionally distributed they are for good political reasons, but maybe not for good economic or environmental reasons. So again, the politics interferes with the rationality of why you do what you do where you want to do it. And the numbers, in some sense, are trivially small, but they're a sort of indication of intent, which might attract private money. But skeptics will say that's not a big enough number to attract any substantive amount of private money. And then these major projects, including Highways Agency extensions on the A14, which is the trunk road from the ports on the east coast to the hubs of the spine motorways and railway systems through the middle of the country, Crossrail, Thameslink, Gatwick or Heathrow capital investment, increasing port capability. These projects now are those which are likely to be given priority, and that cabinet committees, which means all the departments will sit around the table and talk to each other, more importantly listen to each other, which will focus on delivery. And the idea is to obviously deliver better coordination, better planning, fewer regulatory hold-ups, and bring more commercial expertise to bear on the delivery of those projects across the country, all of which have an impact on our economic and social well-being, as well as delivering some of our environmental targets. So what technologies do we need? Some of the technologies are pretty obvious, actually. We need new sensors to find out what's going on. We need new materials to build things with which have lower embedded carbon. But if we want to have better electronics around our environment that are durable to withstand the environment that we put them through in order to understand the state of our infrastructure. One of the issues with the Hammersmith flyover was we didn't know what was wrong with it till it broke. And then when we discovered how much broken it was, of course, the disruption to those of you who travel in from the west of London on a car and manifold. So having plastic electronics, cheap electronics as means of processing, sensing information from novel sensors everywhere in our infrastructure is very important to understanding what the health of our civil infrastructure is. Coming with that is, of course, connectivity and adaptive systems to deal with changing circumstance. So those are some ICT-related technologies, but we've never done things like this at this scale across the whole country. We've done things at small scale. So actually we're going to have to do national stuff. We haven't done many things at national scale for 20, 30, 40 years. Last thing we probably did was gas and the remaining part of the motorway systems. And after we've done all that, are we then going to be locked into solutions that are no longer fit for purpose? So how do we manage adaptability to future circumstances that are quite difficult to predict? So we need to do quite a lot of work in that space as well. To bring me to the focus of engineering, what we also need to do is deliver all of these things: resilience to shock, flood, storms, counter-terrorism, and the fact that we have to sustain it. We have to make it low carbon. It has to be socially acceptable, livable with. It has to deliver economic performance, and it has to deliver the service quality we want concurrently. All of those things, not and, or, all of them. So that's not an easy trick to pull off. We tend to have optimized on economic performance, and then the pendulum swings and we look at low carbon, and then when some bad incident occurs, we look for resilience. But actually, engineers need to think about all of those things simultaneously and try and deliver holistic solutions to our modernization program. And we need to do it at scale, and we need to do it fast. Can we learn from what's going on elsewhere? As I said earlier, a lot of countries are in exactly the same place as we are, so they're all attempting to do these modernization processes in similar ways. And as an example of where we've probably got it right, there's a gentleman sitting at the top there who can tell you more about it. This is a world-beating low-carbon car. with a production line behind it which has all the right properties. This is a really good example of delivery of those 5 things simultaneously. And I won't embarrass you, Hugh, by telling you any more. You can talk to Hugh later. Design. What's in the backdrop here is an electric vehicle made by a company that, the last time I looked, was going bankrupt because there wasn't a big enough market for it. FedEx and UPS are the only 2 players who bought it. In fact, if you look at a UPS delivery vehicle around London, you'll find them still using these vehicles. They're pure electric vehicles for point-to-point delivery. Very efficient. I've driven one, actually. And they're amazing designs. But actually, we like our internal combustion engines, don't we? Actually, this thing out-accelerated almost anything else I'd ever driven, but not for long, because it's quite heavy. But electric vehicles do have that property. So we're very habitual in the way we think about our infrastructure. But can we change our habits by good design? Design is not a word that gets talked about very much. Anthony and I actually talked about it over lunch with colleagues a lot today, as it happened. And secondly, it's certainly in my lifetime, we have become the consumer society. And we have become very competitive because those are the measures we use to describe how we see success. But if we believe we now have to move from consumption, which is inevitable, but now look at collaboration and conservation as well as competition, maybe we're in a different business model paradigm over the delivery of infrastructure, and that in itself is a design process. We need to think about business process design as well as the actual physical engineering. And does that mean more effective sustainability or not? I don't know the answer to that question, but I think that's one of the research questions we need to examine. And then the media, who have a really important role in affecting how people perceive the value of engineering in our society, they could do a lot in helping us deliver a much better perception of the value of good design. Interdependency, I've touched on a little bit. This is a picture of the floods in Gloucestershire, where we very nearly lost a substation, which would have taken out 300,000 houses and a pumping station for clean water, which meant those houses would have been without electricity and without water, which wouldn't have been very clever for 300,000 houses. So we've discovered that energy and IT are pretty well the most critical in this area. Done a lot of studies with John there, John and I, over the last 3 or 4 years. And that water, waste and transport are nearly as critical. You can't really do without all of these things. And what's more, they all interplay with each other. If one fails, it takes out another one. And the linkages between them are pretty well unregulated. They're more or less invisible till they break, and then you discover, oh, I was dependent on that. And they're bilateral contracts largely. There's no system of, or there hasn't been very much system of system analysis or operational management. Now, this is a simplified view of interdependence. I emphasize simplified. That was used in order to analyse the effect of Hurricane Katrina on New Orleans. And this is not a very pleasant story. What happened was the levees broke and the water came in, took out the electricity. The electricity took out the ability for any form of electronic payment to work and for ATM cash machines to stop, which meant people couldn't get any money. And if they hadn't got any money and no means of doing electronic payment, that means they weren't going to have any food and their fridges were going to stop working. This is New Orleans. So very rapidly, the penny dropped that unless they got food in tins very quickly, they weren't going to have any food. Where was the food in tins? In the supermarkets. 8 hours it took for that realization to dawn and the supermarkets to be raided. Now, had there been backup generators or backup electricity supplies or give away money, that social instability may not have kicked in, but it took them days to sort that out and lives were lost as a result of it. So this is a result of, this is just a very simplistic view of some of the analysis that was done post Hurricane Katrina. This is an incident that happened in East Barnet. This is an actual extract from the BBC news site, which I took off 3 days ago, although this happened 2 years ago, and it's still there. I'll leave you to read it, because it's a salutary tale. So in summary, the water froze, cracked the water pipes, the water then thought again, got round the gas pipes, cracked the gas pipes, went into the gas pipes, houses, no water, no gas, no heating, middle of the winter. Electricity company says, actually gas company says, have some electricity heaters, didn't tell the electricity company, and blew the local substation. So it was a complete lack of coordination in emergency response between the three utilities. And it took them best part of 10 days to get that right after the event. 3,000 people affected. And that sort of is, for me, just encapsulates interdependency at a very grassroots level that most of us would identify with as the sort of episode that were you on the receiving end of that? You say, why don't they do something about it? And of course, the they, when you unpick the they, is at least 3 different regulators, lots of different companies who are supplying various elements of these services, who aren't necessarily organised or instructed or incentivised in any way at all to deliver joined-up thinking around the solutions that you are the customer for. So the next steps on all of this is essentially to use some pilot projects of some scale to test out some of these complex analysis methodologies around interdependencies, resilience evaluation, to get the cost down through the whole life cycle, not just what it costs to buy it, but what it costs to operate it, and to change some of the methods by which we procure things. And this activity is just kicking off in the Treasury, and I've just handed this chalice of coordinating some of this to Jeremy Watson, sitting here in front of me. There is then also a move towards getting much better data, because at the moment we have very little data about actually what is out there. We don't know enough to help us understand really what it is we have to modernise. Now, some of you will always say, yes, there are some areas where we do know more, and that is absolutely true. But when you talk about anything of any scale, it's much more difficult. And there's no structured methodology or history of understanding how to curate and exploit data in the context of infrastructure. The whole procurement, client supply chain management, crucial, and there's a lot of work being done in that space as well. Regulators, of which I think there are 37, across the UK for various aspects of infrastructure, are now beginning to understand that they need to talk and listen to each other and provide better regulatory coherence. And then there's the possibility of injecting innovative ideas, both technological, design, procurement, into the way we do these things. Work is already underway to produce a forward look, what it might look like in 40 years' time across the whole of this landscape of infrastructure. Not necessarily that we'd be wedded to achieving that, but at least it knows that we can then agree on a general sense of direction that we're going to move towards in order to provide the solutions that are needed for our developed society to maintain itself as a developed society. And last but not least, and of course very important for an education establishment such as UCL, is where are the people going to come from? So again, the idea that we educate our engineers across a wide range of disciplines and help with the development of trades in a similar way is absolutely crucial to the delivery of all of this, because it's one thing to have all the planning, it's another thing to actually execute it. And then, and even more importantly in some ways to me, is to invest in research in order to understand how to deliver sustainable infrastructure over the next century. And indeed, the research councils have already responded to that in producing calls for proposals in that space. So what is the role of engineering policy in this? First of all, modernising this is about design, engineering, implementing and operating for a sustainable future. Up to now, my observation of infrastructure policy has been that it's really largely been about analysis, economics and politics. The engineering element of it has not been present to a very large extent. It's been patchy and in some cases has been ignored. Whether or not you could actually do something which the policy targets were setting wasn't something that was on the agenda. So if we're going to make this successful, then we've got to actually complement this traditional policy landscape with engineering policy. Otherwise, what will happen will be not acceptable, successful, sustainable, and it probably won't work. Which would be a shame, because we're likely to put a huge amount of money into it. So what do we need? What interventions are needed? So this is the nub of what the centre will be addressing in the near term. Understanding what the role is in policy making, procurement and operation. Where is the knowledge? Where's the evidence? How do we make an impact in policy making, procurement and operation? Then asking some questions about the research synthesizing the answers. I've talked very heavily about integration. A lot of people in this room probably have a job title or know someone who has a job title which is analyst. I bet no one has or knows someone who has a job title which has the word synthesist. Probably because it's difficult to say, especially at the end of a long lecture. But actually, it's because you don't get paid for joining things up. You get paid for decomposing things and understanding bits of it. And actually what we're about here is living with a complex synthesis of various components. That's what we all experience, and we grumble that it isn't working properly, and yet we don't put resources into the process by which we achieve it. We then need to advise people. We need to have networks of people that are multidisciplinary, that help policymakers at a range of different scales, help them do a better job. But all of this is taking place in conditions of uncertainty and even violent disagreements about what the future might look like or what the future should look like. So how do you create policy in those conditions? Because that is the Realpolitik. I think traditionally in the past we've assumed that politicians are outside the problem and therefore become part of the problem. If we put them inside, they're part of the solution because they are then what we're trying to help with. And so the uncertainty and disagreement of politics has to be part of the landscape we're examining so that we then understand what the consequences are of that uncertainty and disagreement, what the consequences will be on the way in which we propose certain ways forward. This all has to be sustainable, and that's not easy when you have a democracy which is causing changes of views about how to do things every few years. By contrast to other countries in the world, and it's quite interesting to do comparisons with countries which don't suffer from that particular perturbation, they suffer from other perturbations, but nevertheless they have continuity of politics. They do things in this space in a different way. Some of us think more effectively. Is there something to be learned from a mixture of those two phenomena? And then how do we work with policymakers and make use of expert advisory processes? And lastly, how do we help with the media to get a better understanding of engineering policy across the whole landscape of society, government, industry, and academia as well? So that's the framework which I'm creating and taking forward. Inaugural lectures can be either this is the work I have done or this is the work I intend to do. Clearly, I'm in the latter category for obvious reasons. So this, I believe, is the state we're sort of living in, which is not a particularly pretty state. However, work's in progress. Two types of people here, one with a hard hat on and one without. But those are both men, and that's not appropriate. So here we have a couple of young ladies with hard hats on, which is really important. And a note of caution, because there is this word smart out there that says smart infrastructure will solve everything. People with laptops and ICT will come and deal with it. Not true. They will contribute, that's for sure, but they're not the panacea, they're not the whole solution. So I think those are the solutions that I put forward in the policy framework. Is we need to work collectively across a whole range of disciplines to make all this happen, and occasionally wag our finger at people and say, no, you're wrong, which I think I was doing on that occasion. It does happen sometimes, but you know, it's what I got paid for at the time. However, Dilbert always has something to say about these matters. So Dilbert, I think, says this about planning, which I think is pretty damned important. You can plan far too much, and it's quite often a good idea to just get on with it and learn by your mistakes, because actually just analysing it to death doesn't get you very far. However, you have to be a bit careful about doing that, so you have to understand where you're going. So a plan isn't enough, and I think having a purpose is quite useful. And then don't believe your own marketing spin, because that's a really dangerous thing to do. But I love the middle one. Benchmarking is sort of out there, and the Treasury love benchmarking. Beware benchmarking, because the comparisons with anybody else have so many assumptions that you cannot really go into that space without a huge amount of prior knowledge of what is really important about why things are good or not good. However, that's where I believe we've got to. We have to understand our context in infrastructure modernisation, and we have to play the whole game with everybody at the table, not in a partial way. Thank you very much.
Ladies and gentlemen, I'm really delighted and honoured to be asked to give the vote of thanks to Professor Brian Collins. I never thought that I would find myself in an institution like this, in a room like this, giving a vote of thanks to a man like this. So I'm glad to do it. I'm grateful that I have the opportunity to thank Brian, if I could put it that way. How do you know if you've been to a good lecture? I guess you can feel it in the room, and I do feel it in the room. And then you say, okay, but what are you feeling in the room? And I suppose if we've been to a good lecture, we're probably entertained. We're probably stimulated. I guess we're probably provoked. It's probably been a very good lecture if we're feeling a little bit less comfortable now than we were before the lecture started. Maybe we're feeling a bit troubled, a bit worried, possibly a little bit inadequate, but we'll get over that. And that we realize that here was something very significant that we'd wondered about, we'd thought about, but now we feel a great deal more than we had in the past. And infrastructure, I think, is a particularly big and challenging subject. I mean, I was thinking, Brian, I guess everyone here was stimulated, and as Brian, as you're going through your lecture, goodness me, I never thought of that. So we've all got our thoughts, and I have the luck to stand here and impose them on you. So if you crave my indulgence, but there are a couple of thoughts that struck my mind. One is that infrastructure is kind of its own worst enemy, isn't it? Because what we want to do is for it to work so perfectly that we don't even know it's there. And because we don't even know it's there, we take it for granted, and when it falls over, it's kind of too late. I guess the other thing is that when we're building infrastructure, we get euphoric, don't we? I mean, when we're building the railways, we got euphoric. When we're building the internet, we got euphoric. And then when we have to maintain it, we get kind of bored. And that's the other difficulty. And then I think you were talking as well, Brian, about models for ensuring we get the investment in the infrastructure we need. And you kind of implied there are some political models that do that better than others. It reminded me of what Galbraith said. I think he said, this is a sort of paraphrasing what I think he said. I looked it up on the internet, couldn't quite find it today. But it's a bit of a kind of a paraphrasing about consumerism and modern market economies that condemns us to drive ever more wonderful cars on ever more potholed roads. And I guess that kind of sums up some of the things that you were saying to us as well, Brian. Brian, I think it was a terrific lecture. I really do enjoy it. I am feeling a little bit inadequate and troubled and concerned, but stimulated and entertained and provoked as well. I think we all realize, and that's the reason we're here, just how important infrastructure is. And I guess the infrastructure of the natural world that lies behind this physical infrastructure that we've created for ourselves, and how important it is we understand it and are able to maintain it, and how important it is we can engage the whole of society and our political systems in ensuring that that gets done. And to the extent I'm troubled and perplexed, somewhat less so, because men of the likes of Brian Collins have this job to engage and study and communicate and stimulate us to do a better job. Brian, thank you very much indeed.
Thank you, James.